Good morning. So my name is Lisa. So I'm going to be presenting the retrofit of my flat, which is down in Shawlands. So it's, as you can see, Victorian tenement flat, ground floor. So I'm going to have to trot through this very quickly to get it done in 10 minutes. It's kind of what you'd expect from a one-bed kind of tenement flat, hall in the middle, big kitchen in the back. 1901 sandstone, blonde sandstone, big high ceilings, so almost 4-meter ceilings, 2.8 meter tall windows, which make them unbelievably expensive to replace, and all kind of the standard things that you would expect. The flat hadn't largely been touched since about the 70s. It was absolutely kind of lethal. Boiler and electrics, all surveyed end of life, 800 mil thick walls, suspended timber floor, kind of, a bit bog standard what you would get in Shawlands that hadn't been renovated yet. So I set very specific objectives for my retrofit, which was to use breathable construction to protect all the original masonry and timbers. Primarily, my focus was improving comfort. So as Jonathan said, I'm an architect and an engineer. My second degree is actually in building physics. And so one thing you kind of learn when you study building physics is that we design to remove discomfort. So basically, comfort is the absence of discomfort. If you remove anything that causes discomfort, so you remove cold drafts, you remove cold surfaces, you remove anything that would glare, et cetera, you end up having a comfortable space. So it's actually defined by its inverse. So my focus was really on improving comfort by resolving all the various elements of discomfort that were in the flat. And basically, if you do that correctly, following good principles of building physics, you should actually require very little energy, because at that point, the building fabric's doing most of the work, and the heating system shouldn't actually need to do very much to then keep the space comfortable. So the secondary focus was actually on energy savings. The energy upgrade costs were recouped by a conversion to a 2-bed, which is currently underway at the moment. Literally, my entire kitchen is stacked up in my living room at the moment. So this is still a project in the works. But the aim was to create a low-energy flat that still retained the character of a Victorian property, because I think a lot of retrofits have gotten the reputation of being quite ugly, EPS kind of smacked on the outside of buildings, things that just look very modern compared to what a Victorian flat would normally look like. So if we look at the way that we understand comfort, the human body, which Gloria Lowe talked on very well yesterday, can sense a whole lot of things. So it can sense a whole range of different comfort aspects. And basically, if you start focusing in on how you remove various elements of discomfort, you start kind of understanding how to approach a retrofit. So there are 3 key kind of elements of heat that you need to kind of be aware of: radiant heat from radiators, ovens, south-facing windows. Basically, radiant heat, as it is, heat that radiates. It also works in reverse, though. So you get a radiant impact of cold surfaces, so cold windows, you'll have a sense of kind of a radiant draw from a cold surface. Convective heat from warm air, and conductive heat from physically touching a surface. So if you understand kind of those 3 types of heat, then you can start picking apart the various sources of discomfort in a tenement. So high ceilings cause temperature stratification due to displacement of air. So all the warm air ends up right at the top, cold air ends up at the bottom. So a way of resolving that is you cut off the cold drafts. Then the warm air can actually sit below, it doesn't get displaced quite so much. I have had glazing without low-E coatings. It caused quite a lot of radiant heat loss, especially at night, so you feel the cold surface at night. Cold surface temperatures for the external walls, conductive heat loss, temperature asymmetry of a cold wall on the outside of the property, warm walls on the inside of the property, thinner walls and joinery at the bay. So this was where I really focused a lot of my energy, is the bays. So the bays, as you know, the masonry cuts in quite a bit, gets very thin. You have quite a lot of joinery, quite a lot of potential for air infiltration, for cold drafts, and just generally cold surfaces at the bay. So I focus a lot of my attention on basically just dealing with the bays, and basically kind of deal with 80% of the problem by solving 20% of the fabric. So service penetrations were a huge source of draft in my property. Once I pulled my bathtub out, I could have actually walked down through my floor. The holes were so big underneath my bathtub, which explains why I could never get a warm bath. Gaps in the floor perimeter around the surface board and floors being a source of conductive loss as well. So basically that set out the brief for what I was going to do and the different kind of measures that I was going to undertake. So the big thing is, and we all know in tenements, drafts. They are just drafty. And I say this, when I moved into my property, I was standing in the kitchen the first couple of weeks, and it was a really windy day, and I was making like lunch or something, and I was standing in a dress, and the wind blew, and literally my skirt flew up. So I had like a Marilyn Monroe style kitchen. So that was a big kind of thing to sort out. So I basically sealed between the floorboards. I used timber slivers. I would never recommend doing this. It was unbelievably labor intensive. It looks beautiful, but holy crap, it's really backbreaking. This was probably the most, I think, really clever solution. Basically, I just used air tightness tape around the perimeter of the flat. So in most cases, I used it behind the skirting board. In this case, the skirting board was in really good condition, so I just used it on top. That basically just sealed the whole perimeter of all the rooms. To be honest, that cut down the drafts massively in the property. There's a huge amount of air that comes through the perimeter of a suspended timber floor. So to be honest, you yank the skirting boards off, put the air tightness tape down, tape up the joint between the floorboards and the wall, put the skirting boards back on, you won't even notice it. In this case, I put a kind of decorative architrave to cover up the tape, but that worked extremely well, and you can kind of see from the thermal image. Traditional joinery, so there was a couple points where I didn't have the stomach to pull out the joinery because it was kind of the nice original stuff mostly. So I basically just draft-proofed the crap out of it and used tape anywhere that I could possibly get tape. Covered it up with some nice bits of beading and just made the whole thing very airtight, and it actually worked beautifully. I have since modified that a little bit, which I think I come on to. This is one detail that's quite common with anyone that's got replacement UPVC windows in what would have been original timber sash frames. So a common detail is that basically they put these weird mock sills on top of the old sill plate for the window. It's usually drafty as anything, and they just put a little piece of UPVC in the front. Basically, it just howled wind through that thing. So I did the one thing that I tell everyone never to do, which was use spray foam. This is probably, I quite pride myself that I only used 5 cans of spray foam in my entire flat. So I'm quite proud of that, but this is one of them, is basically just to seal that up. So ideally, once I win the lottery and I can pay for 3-meter tall double triple glazed windows, I'll replace those, and it'll be a mess to pull it out. But in the meantime, that actually did produce quite a big impact of reducing the sound infiltration, reducing the air infiltration, and also making it a bit more insulated on the sill of the windows that I couldn't replace. So once you take all the drafts away, you do actually have to provide air. So it wasn't viable to do an MVHR system because basically there was no straightforward way of running a supply duct out to the bedroom. I could have gotten supply ducts to anywhere else in the house except the bedroom relatively easily, but the bedroom's also quite the critical one to get a supply duct to. So basically I just did centralized mechanical extract ventilation, so it pulls continuously out of the bathroom and the kitchen at very low level. It requires only 1 core drill through the external wall. It's quite quiet, so it pulls at very low level 24/7, and then it boosts based on humidity. So if you cook, you have a shower, it'll boost in that room for a period of time until the humidity resolves. Heating, I basically just went for a straightforward combi boiler. In hindsight, to be honest, it's not the most efficient way of doing it. But that said, I sized the radiators down knowing that I was going to insulate and make airtight the whole flat. The right now the heating load of the building is so low, it would be quite easy to switch over to a heat pump, and I would actually get very, very good efficiency out of it. So it's combi boiler for the time being. It probably won't be in the long term. So the insulation stuff. So the big win was 140 mil Pavoflex bats in the floor. So I used lime packing in the joist ends to basically protect the joist ends. It was, I can stand under my floor, so it was relatively easy to install it. Did whack my head a couple of times and almost knock myself out, but I learned not to do that when I'm alone in the flat. So I did install a wind barrier, again, because I seemed to be in quite a vulnerable wind location in Shawlands, oddly enough. So I did install a wind barrier underneath the insulation, and that actually has had a really good effect, really good impact. So one, it holds the insulation physically in place. Two, it acts as a bit of a vapor barrier to reduce how much vapor infiltration you get from the ground, and also just reduces the wind washing. So some of the things I did on the bay: internal wall insulation, internal wall insulation in the bathroom. So my bathroom happens to be in a very exposed location facing southwest, gets absolutely pummeled with rain. I used calcitherm specifically because it maintains its dimensional qualities when it gets saturated. There's different opinions as to whether or not that was the right thing to do. Personally, I think it's a very robust thing to do. Probably could have gotten away fine with wood fiber, but either way, it's fine. Comes out really nice, looks lovely. Bathroom's nice and toasty now. And I used dianthenite as a kind of leveling layer behind, and you can't see it too well here, but at the top of the wall at one point, I'd only partially installed the calcitherm. So it was dianthenite on the right-hand side of the wall, and calcitherm on the left-hand side above the window. And you can see on the thermal image the difference between the surface temperature of the two. It's a pretty big difference. And I have to say, I'm pretty sure at that point the dianthenite hadn't completely dried. I was kind of hurling everything on the wall relatively quickly. So this is where the other spray foam got used. And this was one of the joinery bits that I just didn't want to pull apart. Basically, with a kind of energy crisis, I just had to sort out one of the bays on the north side that was freezing. So I wanted to use isonine, which is a much more vapor open spray foam, but basically there was a supply issue with Brexit, couldn't get it. So I sort of just bit the bullet and used the no-nonsense stuff out of Screwfix, but drilled holes, squirted it in. To be honest, it's made a massive difference, and it's only a couple inches thick, so I kind of figure it's quite a minimal risk of causing a problem on that side of the building. Window shutters, also really good thermal retention. So, now this is the last bit. Does it work? So this is the comparison of annual energy consumption. My flat in pink, and my neighbor's flat in green. I apologize if any of you are red-green colorblind. So basically I use about half as much energy as my next door neighbor. The exact same building, the exact same flat, just mirrored on the other side of the close. The energy company kind of gives you kind of monthly summaries of how many kilowatt hours per day you use. So I kind of tracked back for 1 month for September in 2019. It was 31 kilowatt hours a day for September as average, down to 26, down to 17, now down to 14. So as I've been making improvements, you've been seeing like quite significant improvements as it goes along. And then that is the annual heating for basically since I've moved into the flat. You can see the shoulder seasons get significantly less. So for this past year, which is in blue, the amount of heating that I now use in December is roughly what I used to use back in September at the beginning of the works. So the shoulder season has been massively reduced, and that's had a massive impact. So approximately 50 to 60% reduction in heat energy. And that's all. Yeah.
So this is Balbougie Steading. My wife and I bought this back in January 22. It's located in Fife, just north of Inverkeithing. You can see the Forth Bridges in the background. It's got views over to the Forth Bridges and back this way to Edinburgh. it was in a terrible state. The roofs have fallen in. This is the old stable block with some of the sort of saddle storage on the walls, but also the roof on the floor, and trees growing through it. The other end of the site, this is showing sort of the barns and a machinery shed. This project is a little bit further than retrofit. It's rehabilitation. I've come to call it nursing a sick child, old person. The planning we have, and maybe not what we build, but the planning we have is to create an art studio for my wife's business here at the front, to create a auxiliary dwelling here on the left. Sorry. Auxiliary building here on the left that would be used as our currently as at first as our place to live, but in future for sort of ailing parents, and the other end a new build house. But this is planning, not reality. We'll see how far we get. And at the back, a central plant room to maximise whatever renewables or heat pumps, etc., that we use, as it will be only our family moving around the site. It's about 1,200 square metres, so it's significant, and the business is the driver for this project. The project also has, we're doing a lot of work to work with the environment and to bolster the biodiversity on the site, and we have 5 acres of woodland behind it's ancient woodland, but it's not been particularly looked after. So movement of sheep into it and out of it. There's lots of other sort of threads coming together. All the demolitions that we're doing are being used to temper some of the groundwater that causes us problems. Lots of problems. It's quite a historic site. This is the 1850 map, but it appears on maps back to about the 15th century. So it's we keep on fighting, and most of the steading is built from a quarry that's on the hill behind it. The building on the left is the stable block, as I was discussing, and on the left-hand end of that is what would have been the stockman's bothy, where he would have stayed to look after all the animals over the night originally. Had a forge and a fireplace in it. This is about April last year, 22. Me and my father-in-law cleared that out. It was a geology of waste. At the bottom there was a purple wobbly thing that we still don't know what it was, and we just put it in a box and threw it away. We've only used 3.5 skips so far, to go back to Roger's point yesterday. I think I'll just run you through very quickly the materials we use. So it's 160 of hempcrete directly cast against the walls. We've worked with UK Hempcrete to do dynamic modelling and to look at the moisture risk analysis and the U values. This was kept slightly short to make sure some heat went into the walls, because letting the walls get too cold, they're 600 wide, would actually bring ingress of moisture from the outside and reduce the U value. So I thought that was quite interesting. The roof we chose not to cast in hemp fully for reasons of leakage through the Douglas sarking we've used on the inside. I think that was a mistake. We could have cast the whole thing. It wouldn't have leaked through. Looking at once I got my hands into it and realised what it felt like. But we used hemp blocks instead, covered with sheep's wool, and then over the whole thing a 100 mil of wood fibre board. That's the UK sourced Douglas fir, far more difficult to source and a lot more expensive than getting it from Canada, which is just bonkers. We use Glayport underneath the slabs, which is an insulating glass foam, and we use cork on top of the slabs to achieve the U values we were looking for. We used diathanite in areas where we wanted to cut in against original features. And came up with some details, like using the block to create a new sill. So that's what it looked like when we began. That's what it looks like now. And this is where I start to trip up, so I'm going to use my notes. It's taken us a year to get weather tight, and it would have taken us less if I'd spent more time trying to plan how all the elements go together. This is going back to Scott's point yesterday of admitting your mistakes, which is pretty much the rest of the talk. Early in the design process, we decided to run with a timber roof, which was evolved into an off-site build. And the off-site build then meant cranes, it meant scaffolding. And at some point they dropped it on us that if we really wanted to protect the Douglas fir, we'd probably need a temporary roof. This wasn't in the plan, wasn't in the thinking, but we went with it. And we'd have to integrate with the hemp as it was cast and the internal structure. So all those things needed to happen within a period, within a combined period. So you can't fix the internal structure to the walls without, you have to do that, and then you have to cast the hemp around it, but you have to have the roof on, and you have to have the roof protected, but not protected enough so they can crane the bits in. So it was 1, 2, 3, 4, 5, 6, and as we know, that kind of planning doesn't work, does it? And on the other side of this, it's all happening beginning earlier 22. The engineers decided that it would use more carbon to build a frame inside the building and to reinforce that frame underground with the added structure, reinforcement in concrete than it would be to underpin. So that was another interesting moment, but the underpin then meant we were using the existing walls to take the structure. It flipped where we were going to do the stonemasonry. It extended the period after the groundworks, and the roof was already in production. So we ended up with a collision between the two elements, which left me less and less time. This is Vinny, just showing how difficult and long-winded underpinning actually is. The original ground areas we had earmarked as well. This is sort of bringing in some of the vagaries that happens on a lot of building sites. But the original ground worker, who was very happy to do the work, lost some of his staff during sort of the early part of last year. They walked out because they didn't feel they were being paid enough, and he could then no longer do the job. It delayed us a few months getting started, as well as everything else. So we did get a new ground worker in, and he's been amazing, and he's saved my bacon on 2 other occasions, as did lots of other people. These are actually the hempcreters. I knew that Ronan on the left was a stonemason in his previous life, and when we were up against it with the stonemasonry and our stonemason couldn't do all the work the engineer had finally sort of decided upon, I asked him to come up and help out. So that's him and his brother helping us get to where we needed. That's whinstone. It's some of the heaviest stone I've ever felt. It's 2 or 3 times the weight of granite. I don't know how they're lifting that stone. Our stonemason did things like put heli bars in and taught me and my father-in-law to mix mortar. So that's my father-in-law, who I think is watching online, to do his, to help me get where I needed. This is the ground workers putting in the glaze pour. This is the over the top of that, the slab going in place. This is Thomas, who didn't really understand what the glaze pour, didn't really like the glaze pour, couldn't use the compactor on it. It just went everywhere. We phoned Hempcrete, and we phoned UK Hempcrete, and they said, try doing it with a piece of plywood on top of it. It's sometimes you're just sort of wondering about exactly how you're supposed to do these things. Slabs in, but slabs in, herein is the biggest mistake I made. Knowing that the roof needed to be on site, it'd already been waiting 2 or 3 weeks in their studio, in their workshop. I chose not to put the external drainage in and got the scaffolding up for the roof instead. The roof went in, and it was a lovely day. Looked great. You started to feel the spaces and what it was actually going to be like, and thought, okay, I'm getting somewhere. The hempcreters arrived quickly on their heels. This is them putting Wattstop on to stop some of the ground raises behind the building. So this is just to sort of resist some of that moisture. And then quickly after, the hempcrete itself, you can see them batching out here and the casting going on. You also see in that moment we've had to put up all the internal timbers around their working. So the Wattstop goes on, then the timbers, then the hempcrete. So we're trying to sort of juggle them on site. At the same time, it was -7 this week, and we were wondering what it was doing to the hempcrete. They've done it before in those temperatures, but it was still worrying me slightly. And then that's it when it starts to come down. That's the hemp. on its first sort of, what's it going to look like. These are great. These go through the walls. They're on the predominant prevailing wind side of the building, and they're baffled air vents for the original stable to keep pathogens down and ventilate the building. I still haven't exactly worked out how I'm going to use them, but I'm going to use them. People left site in December. This is my daughter. She became a great friend of Thomas's. The hempcreters went home. The ground workers could get no further with the drainage, so I was left to my own devices over Christmas, and the weather got ugly. And this is Christmas Eve. This is the temporary roof. I would never do it again, for more than one reason. They were terrible getting it installed. It took so long. It got in the way of the other people doing their jobs, the hempcreters and the people installing the roof. And then it leaked. And it didn't just leak, it leaked like plastics leak in a sort of constant damaging kind of torrent through certain parts of the roof where it would come unstuck. And I found myself with COVID on Christmas Eve with a small child at home being excited about Christmas, and my wife also heavily pregnant and with COVID as well, crawling around on this roof like some sort of bad Santa, expleting into the darkness. I hope the neighbours didn't hear. But it wasn't the worst, because on Boxing Day I went back to see if my plan had worked. The roof was dry, but the water was coming in through the foundations. On the 28th of December, James Penman, the ground worker, came with his two sons, who were standing in the background, and he dug me out a sump, and we started draining water from what basically ground was clay, it's on an escarpment, there's passage of water coming, we knew that. We had also cut through a couple of original stone culverts that probably come from an overflow in the main house, but were as dry as a bone, right up, even when it was raining, dry as a bone, because they're obviously there for extreme deluges. And at this point, there was places in Dunfermline flooding under, 60, 70 centimetres of water. There it is running, that culvert. So we knew at that point what was happening. So what essentially happened, we built a sink and with multiple taps into it and no plug hole. And until we could get a plug hole in there, we'd have to rely on this pump. I spent most of January working that pump, going back and forth, looking after it, trying to make sure that everything was, sealed and closed in. And I knew that Laurie, my son, was going to be born in February. So both these are bundles of joy. This is Stevie, and he came to help us in February. James Penman's third gift to me was introducing me to Stevie, who at first was like, I'm not working on that building, I don't understand anything you're doing. What are these materials? Where's my foam? Where's my plasterboard? I don't want to do it. And he actually said no, and then James talked him back into it. He was brilliant. He's been brilliant, and we progressed the roof whilst we worked out how we were going to get the inside of the building dry. See, the problem is the hempcrete is hygroscopic, and if you've got a wet floor or even a damp slab, it's picking up all that moisture. And I then we spent the first part of the year, the spring, chasing the moisture, dehumidifying, ventilating. If it got, to some low-level heating at certain points to just make sure that that water's not going back in the wall. But this isn't great, right? I'm trying to do this as a low-energy, low-carbon project, and now I'm having to pump heat into an open building. And there's sort of bits like corners and stuff. You could just see that I was going to get into a bit of trouble. And the weather didn't let up. This is March. So that's it, mould across the whole surface. No one wants to see mould. Even though Hempcrete and Hempcrete Cymru was like, no, you're fine, don't worry. We've seen this before. It just happens when it gets too wet for too long. It won't be a problem in the long run, but it just worries you. It's not nice to see when you put all this effort in. May came, sun came out, the scaffolding came down, the roof matched the tatties going in the field, so that was a small pleasure, but and continued to be sunny for a few weeks, and everything started to dry out, apart from a few areas
And again, it dawned on me that we'd cast this wall up against a wet wall, and we hadn't yet finished the pointing on the outside. You can see those air vents on the outside there. So we set to about making sure that we'd sealed up the exterior building and we'd finished the pointing. This is Alex Sparrow from UK Hempcrete. That's the guys from Hempcrete Cymru up on the balcony there, and that's Stevie giving them a hard time about, you know, what happened and why. Far more aggressive than I would have been. That's what we had to do. We then created a large French drain around the building and put some holes in to drain it. That's it, fully pointed. That's me and Stevie coming up with details. Again, when you've got a standard window and a standard jamb detail, it's easy to put your building together, putting products together. But when you've got sort of things built up out of other materials, you've got to come up with these solutions every time. Finally, the R400, something demanded by building control for the radon, had to go in, so that went down, cork went down, and it began to look like the building we'd hoped, and the hempcrete began to come back to looking like it was. That's the same picture as the one at the beginning with all the rubbish on the floor. So again, feeling like we're getting somewhere. And basically, yeah, I think natural materials need to be thought of. Well, they're the opposite to plastic, right? Plastic's great. We got drunk on plastic because it's easy, it's dead, it's immobile, it doesn't do anything. It's that same problem. You know, that's the same problem that causes us all those troubles with it now. It doesn't work with us. But when you work with complex materials, you've got to deal with their complexities, their personalities, and you've got to give them the time to do that. So I think that's my takeaway from this, is that I've really got to, the next stage has really got to plan what we're doing. This is just as my final point, this is a next building that we're working on. That's a steel frame, it's gone, we've taken it down, it's gone to be cleaned, repurposed for a new building on our site and coming back, repainted. That's the first time that's happened in the UK for steel building to be reused. So hopefully next year I can talk about that one.